old saying, where there's a will, there's a way. But the way is not always clear with a problem as large and as complicated as recycling. Global rates for plastic recycling are as low as 9%, and only 6% of new plastic is made from recycled products. To encourage more buy-in, innovators must make recycling as efficient and cost-effective as possible, which is why companies are turning to AI and big data.
Rory, why is plastic
goes into which grade?
There is a lack of standardisation in packaging and recycling ability. Every country and the local authorities within it have different systems. That means that not all grades or all types of plastic that can be recycled are being recycled. That's where advanced machine learning can help. This is the RE3 recycling plant in Reading, England, managed by FCC Environment. I've come here because General Manager Rory Bryan is always on the lookout for ways to improve how much waste can be recycled. Looks cool, but it's just the muscle. It's the brain, the vision technology I want to see, which has been developed by Recycle Eye. The robot arm is connected to LED lights, a camera and a computer. Here it's programmed to separate out the plastic, which will be sold and recycled. And blows it to where it's instructed to by the computer. Any plastic that's not a milk bottle goes off for further processing or burning, as does the waste blown into bins off the side of the belt. Milk bottles are the grade of plastic worth the most money. This system helps ensure the client is getting a higher percentage of what they paid for.
So it's important
To understand, the algorithm is the clever part of Recycle Eye. Many of us associate the word algorithm with the web and social media such as Facebook. There, the algorithm shows what is most relevant to the user, so it will give you more of what you click on. Recycle Eye uses a comparable machine learning algorithm. According to engineer Nick Castano, items are called banding boxes. Each has a number. The higher the number, the more certain the program is that it's been correctly identified. Clients were excited by the possibilities of Recycle Eye, but they wanted to see a prototype fast to show it could work on an industrial scale. That's when Jan Glaus. The robot arms are made by Finnick, the second largest robot manufacturer in the world. Recycle Eye takes the arm and builds a new product. Jan spent time developing the pneumatic air-controlled system so rubbish wasn't blown across the room. But he had another priority. Clients send the team boxes of waste. Images are taken which are then fed into the algorithm. Every client has its own model or program depending on what they want to recycle. But it's not just the clients who are benefiting. The Recycle Eye team has created a database of these images called WasteNet. It's freely available to students and researchers, which could help the recycling industry continue to find better solutions.
Yeah, so every year we have done projects with the students at Imperial College London. It's really exciting to get young engineers involved in waste, thinking about computer vision, how it might be beneficial to the industry as a whole. And we generally give them some of the harder questions that we kind of don't really know whether they'll work, and they really surprise us sometimes with the results that they have. So it's been a really good collaboration where we kind of try and stay on the forefront of research in terms of computer vision, and especially computer vision applied to waste. And that really enables us to push our tech stack further.
WasteNet has over 2.3 million items so far and counting.
Different clients, different locations around the world have different customs and different regulations. So, for example, a bottle that contains bleach might be made out of PP in the UK, but be made out of HDPE somewhere in the Americas.
And that's a different kind of plastic.
It is a different kind of plastic, it has different value points, and it is recycled in a very different way. So by being able to know geographically what the differences are, we can end up providing different sorting schemes, which means that they can be recycled more efficiently.
The amount of plastic that's being produced, so that goes up every year. The cost of plastic, recycled plastic, goes up every year. And that's really building this marketplace where you need high quality sorting and you need high quality automation to just be able to deal with the load.
At the RE3 facility in Reading, the Recycle Eye system came as a kit and was put in over a weekend. Since then, Rory has kept his own eye on the performance and the data it's producing.
So once it's programmed, it knows what it's doing. It always does that. It doesn't get tired. You know, it's constantly focused. It makes sure that we can prioritize on the main materials to get the purity correct. And the other thing that we get, the bonus, is the vision technology tells us exactly what's on that belt. So we will be able to tell how many items of material have gone through there, what those materials are, how many the robot picked. You know, so we get a lot of data from that. That enables us to look at the plant and make sure that it's performing well in all of the other areas.
Identifying new waste streams that could be recycled is a bonus, but the priority for Rory is to ensure the highest purity of each bale, meaning it's as close to 100% of a certain material as they can get. That makes it easier to recycle.
So what improvements have you seen since you've installed Recycler?
So we've seen two main improvements. We're now getting up to 99% purity with the finished product, with the HDPE. So that's less than 1% contamination. You know, and historically we was probably getting around sort of 95 to 98% on that.
It doesn't sound like a great improvement.
It doesn't sound in percentage terms, but of course in volume, when you're handling hundreds of tons, that's quite a big improvement, you know. And any improvement is good because it means that we've got a sustainable outlet for that material. One of the other big improvements we've seen is a 12% increase in the amount of target materials picked from the belt. So that means that actually there's been an increase in recyclables taken from that belt. So that saves further processing costs.
Any improvement is welcome, and Recycli is busy with 17 vision systems dotted around Europe, the US and Australia.
So what's next? Is it merely about selling more units?
Yeah, so at the moment we can produce a limited number of units, and we're actually backed up with orders until mid-next year. So we really need to be able to service the demand in the industry and be able to scale up the number of robots that we can deploy. So that's one of the stages, but also thinking about new products and new ways of identifying and pushing through the capabilities of the sorting industry much further.
Some of the numbers you heard may not seem impressive, but humanity is on a journey towards a circular economy where nothing goes to waste. And Recycli is another step on that journey.